Hi, in this video I will share the previous year's question paper on the Master of Computer Applications Term End Examination June 2023 of Subject MCS 212, Discrete Mathematics. Using induction, show that the following statement proof. To prove the given statement using mathematical induction, we'll follow the steps of induction. Base case, n equals 1, the equation is so, the base case holds. Inductive step, assume that the formula holds for some arbitrary positive integer k. We need to show that it implies the formula holds for k plus 1. Starting with the assumption. Now, let's consider tk plus 1. Substitute the assumed formula for tk. Simplify the expression. So, we've shown that if the formula tk equals 2k minus 1 holds for some k, then it also holds for k plus 1. By the principle of mathematical induction, the formula Tn equals 2n minus 1 is proven for all positive integers n greater than or equal to 1. The question is, in how many ways can 20 employees be assembled into 3 groups? The number of ways to assemble 20 employees into 3 groups depends on whether the order of the employees within the groups matters and whether the groups are distinct. Groups are distinct, and order within groups matters. In this case, each employee is assigned to a specific position within each group, and the order matters. The number of ways to assign the first employee is 20, the second is 19, and so on. The total number of ways is the product of these possibilities for each group. Therefore, the total number of ways is 20 times 19 times 18. Groups are distinct, order within groups doesn't matter. If the order within groups doesn't matter, it's a combination problem. We can use the formula for combinations to find the number of ways. Here, n is the total number of employees, r is the number of employees in each group, and n denotes the factorial of n. Groups are identical, indistinguishable, and order within groups doesn't matter. If the groups are identical, but the order within groups doesn't matter, it's a partition problem. The formula for distributing identical items into distinct boxes is used here. Here, n is the number of employees, and r is the number of groups. Explain isomorphic graphs with suitable examples. Isomorphic graphs are graphs that have the same structure, meaning they have the same number of vertices, the same number of edges, and the same connectivity, but their vertex names, labels, may differ. In other words, isomorphic graphs can be obtained from each other by relabeling their vertices. The example of an isomorphism graph is described as follows. Conditions for graph isomorphism: there will be an equal number of vertices in the given graphs. There will be an equal number of edges in the given graphs. There will be an equal amount of degree sequence in the given graphs.